Question 1 asks if this formula is a tautology. So a tautology is something that is always true. So if we want to find out if this is always true, what we're going to do is negate it. And then we're going to see, so now we have the negation of the formula, and we're going to check if it's possible for this negated formula to be true. So we're checking if it's possible for the original formula to be false. So if we find if we find that there's an open branch, that means it's possible for the original formula to be false. So that means that it's not a tautology. But if it closes, then it's impossible to be false, so that means that the formula will be true. So got my tree set up, and first rule is the main operator here is the negation of the disjunction. So I'm going to follow that rule, which is just the same as for earlier when we were doing propositional logic. So I get lines 2 and 3 from line 1 using the negated or rule, and I can tick off line 1. And next I'm going to decompose these lines 2 and 3 using our new quantifier rules. So let me do line 2 first, which is the negation of universal. Get there exists an x, not fx. So now I've applied to rule 2, I've applied the negation of for all rule. And let's decompose line 3 as well. Got negation of exist x, and that gives me for all x negation of fx. Line 5 comes from line 3 using negation of existential. And now I've got left to decompose. I've got an existential and a universal. So it's always a good idea to do existentials first, and anyway we don't have anything to apply the universal to yet anyway. So I'm going to use the variable a, and I'm going to write negation of fa. So now I've decomposed this formula. I'm sort of naming the variable that exists. We're saying there exists some x for which this is true, and I'm just going to name it a and say that it's a that this existential is talking about really. So number 6 comes from number 4 using existential variable being a. And now I do have something I can apply line 5 to. I've got the variable a, so I'm going to do that. I've got not fa, and now I've applied this to a. So remember, writing this doesn't mean that this is fully decomposed, because if another variable pops up later on, would also need to apply this to that variable, maybe b or something, but we don't have that yet. So I got line 7 from line 5 with all applied to the variable a. Now I can actually see I've got a contradiction, because I've got not fa and not fa. That's a contradiction, and this tree closes. So that tells me that we couldn't find a way for the negation of the formula to be true. And that means the formula is always true. So is it a tautology? Yes, it is a tautology. So moving on to question 2. This one also asks if the formula is a tautology. So it'll be the same strategy. And we're going to negate the whole formula and see if it's possible for this negation to be true. I'll set up my tree. And the main connective here is the negation of a conditional. So we know what to do with that, same as always, just like in the trees from earlier in the course. We have the first formula being true, x exists y, rxy, and the second formula being false, does not exist x for all y, negation of rxy. The lines 2 and 3 I got from line 1 using the negation of error rule. And I can tick that off. So I'm going to be decomposing these two formulas because they look like they need it. So let's do negation of for all is exists x, negation of exists y rxy, and that came from line 2 using the negated for all rule. And let's do line 5, negation of an existential. We have for all x, negation of for all x, negation of for all y, not rxy. And that came from line 3 using the negation of the existential rule. Right, now I'm going to focus on this line because it's got an existential, and so I can use that by putting in a variable for that, and I'm going to call it a. So I copy out the rest of the formula, but everywhere I see an x, I put an a instead. There does not exist a y, r, a, y. And so I've got line 6 from line 4 using the existential rule, and the variable we used was a. Now I've got another negated existential over here, so I'm going to decompose that. That gives me for all y negation of ray. Now I've decomposed that, I get line 7 from line 6 using negation of existential. I'm going to go back. So yeah, what I've got over here is I've got left to decompose two formulas. Both of them are universals. So it's a good idea to have a plan before you apply variables to a universal. And I do have this variable a now, so I could possibly apply it in this formula in line 7, or I could do it in line 5. Remember, what I'm looking for is a contradiction, and I can see that if I applied it in line 7, it would be applying to y being the second variable, but if I applied it in line 5, it would apply to x, which is the first variable in the r relation. And I can see there's sort of like a negation of r thing going on here, and maybe a negation of r thing going on here as well. So I'm going to start by, so basically I can see the a's lining up more in the first variable of the r relation. So yeah, so I think I'm going to apply it to line 5 first, so I can get an a in there, and we can see if we can get a contradiction with something I've already got. So what happens if I do that? To line 5, I get not for all y, not r, a, y. Now I have applied line 5 to a, and I get my line 8 from line 5 using the for all rule with that variable a. Now it looks like I don't actually have to apply any more universals because I've got a contradiction right here, and so I've got this formula and the negation of it right below it. So that is what's going to close my branch, is the contradiction between line 7 and 8. Yes, so what have we found? We found there is no way for the negation of the original formula to be true. And so that means the original formula is a tautology, so the answer would be yes.